x equals, our b term is this, so negative, negative 6. Two negatives make a positive, so this will be 6, plus or minus square root of negative 6 squared is 36 minus 4 times 7 all over 2. Then 4 times 7 is 28. So 6 plus or minus the square root of 8 over 2. Now, because this is not a square number, can't do anything with it yet. But you can simplify it by using radical simplification. This becomes 6 plus square root of 8 over 2, and then 6 minus the square root of 8 over 2. 8 is really 2 times radical 2. Now, if you look at it that way, all of these numbers have a factor of 2 in them. So simplifying, that would be 3 plus radical 2. Since it would be over 1, it's just plain. Same with this. Then 3 minus radical 2. These are your roots. Now this one. Now in the next problem, we're going to again write out x equals and substitute negative 2 plus or minus the square root of 4 minus plus 4 times 30. In a normal equation, this would be minus 4 times negative 30, but the two negatives cancel each other out. Also, since there's a 1/2 and it's 4ac, it will be 2 times 30 over 1. Then negative 2 plus or minus 30 times 2 is 60, plus 4 is 64, all over 1. So negative 2 plus or minus 8, so negative 2 plus 8, negative 2 minus 8, 6, negative 10. These are your roots. Using this method, you can solve any quadratic equation. This is because it's just substitution into a formula. But radical simplification can get a little difficult, though. The fourth method that you can use is factoring. First thing you do is you isolate all terms onto one side, then set the equation equal to 0. After that, check the discriminant, which is b squared minus 4ac. If this is a square number, then the equation can be factored. If it's not a square number, the equation cannot be factored and has to be solved using another method. Then check to see if there's a greatest common factor, such as 4 in the equation. If there is, factor it out. Again, 2x squared plus 6x plus 8, that can become 2 times x squared plus 3x plus 4. Then check to see if after you've done that, check to see if there's a number in front of the x squared. This is where your directions will split. If there is no number in front of the x squared, find the factors of your c term that add up to your b term. Remember, your original quadratic equation will look like this. Now your factored quadratic equation is going to look like this. X plus p times x plus q. The factors of c that add up to b will be your p and your q terms. Fill them in. But remember, if one of them is negative 5, it's changed to x minus 5. There's going to be one x term in each one, since x times x is x squared. And you're just going to write the x's in. If there is a number in front of your x term, multiply the ax squared and c terms together. So you're going to get ac x squared. Then find the factors of this new term. It'll be ax times cx. No wait, zx times dx. These coefficients will add up to your b term. Take out the original b term and rewrite it as ax squared plus zx plus bx plus c. Then divide the equation in half, two terms to a side, remembering the signs. On each side there's going to be a common term. For example, in 2x squared plus 6x, if that's one side of the equation, the common term is 2x. This will become x plus 3. And on the other side, let's say you have 7, x plus 3, as your plus 7 minus 7x minus 21. Then your common factor will be negative 7 times x plus 3. This little parenthesized chunk, x plus 3, has to be the same in order for you to continue. Take that chunk, and it's going to become your x plus p. Then these two terms, the ones that you're multiplying the chunk by, will become this will become your second x, and this will become your q. Once you have them in x plus p, x plus q form, you do this for all of the equations that you have. When you have this, take each parenthetical group and set each parenthetical group equal to 0. So x plus p equals 0 and x plus q equals 0. Even if there's a number like 2, set it equal to 0 as well. You'll just get 2 equals 0, which is false. And that'll just be a wrong answer. Then solve for x in each of your parenthetical groups. That will give you the 2 roots. Now here are